Z-score problems using normal CDF, inverse norm, and percent. Here are the steps to solving Z-score problems. The first step is to input the values given to you in the problem into n. N is mean, standard deviation. Step 2 is to draw and shade the distribution curve. Step 3 is to find the z-score. And step 4 is to use normal CDF or inverse norm to find the final answer. Here are some must-knows for this topic. To start, normal CDF finds area using z-score, while inverse norm finds z-score using percent. The formula for finding z-score is z equals x minus mean over standard deviation. Be sure to put parentheses around x minus mean, or you could get a completely different answer than what you're looking for. Here are some examples of z-score curves and normal CDF. If you're shading to the left of the z-score curve, you're going to want to do normal CDF, -10, and then the z-score. If you're shading to the right of the curve, you're going to want to do normal CDF, the z-score, and then +10. If you're trying to find the area in between two z-scores, you're going to want to do normal CDF, the lower z-score, and then the higher z-score. Now let's begin to do a practice problem based off the stuff we just learned.
The football dogs have a mean running speed of 25 miles per hour with a standard deviation of 3 miles.
Charlie has a running speed of 27 miles per hour. Which percent runs faster than 27 miles per hour?
To solve this problem, start by finding n. 25 miles per hour is the mean running speed and 3 is the standard deviation. So write n, parentheses, 25, 3, close parentheses. Then we draw the curve. 25 goes down the center and 27 goes to the right of the 25. We then shade to the right because we are finding what percent is faster than 27. Then we solve for the z-score. The score is calculated to be 0.667. Then we do normal CDF, parentheses, 0.667, 10, close parentheses, and this comes out as 0.2524. 25.24% of dogs run faster than 27 miles per hour.
For a dog that is in the top 10%, what is their running speed?
To start, let's set up n. For this, we can use the n value from the last problem. Next, we draw the curve. The mean of 25 is in the middle, while x is to the right of it. Now we shade to the right since it's the top 10 percentile. Now we do inverse norm, 0.9, because we're finding the z-score based off the top 10%. This comes out to be 1.2816. Now we will reverse solve the z-score in order to find the x value. The x value comes out to be 28.8447, which means that a dog in the top 10 percentile will have an average running speed of 28.8447 miles per hour.
Out of 50 total dogs tested, how many ran between 23 to 25 miles per hour?
To solve this problem, we use n from the last problem. Then we draw the curve. 25 goes down the middle and 23 goes to the left. Then we shade between 23 and 25. Now we find the z-score for both 23 and 25. Next we do normal CDF, -0.667, 0, which comes out to be 0.2476, which we then multiply by 50 because we're testing 50 dogs. This comes out to be 12.38. Sophia's dog runs 20 miles per hour. What percent of dogs are slower than 20 miles per hour? To begin, we can use n from the last problem. Now we draw the curve. 25 goes down the middle and 20 goes to the left of that. Then we shade to the left. Next, solve for the z-score with 25 as its mean, 20 as its x value, and 3 as the standard deviation. This comes out to be -1.667. Now we do normal CDF, parentheses, -10, -1.667, closed parentheses, which comes out to be 0.04776. This means that 4.776% of the dogs ran slower than 20 miles per hour.